This is just a speeded up series of animations just to remind you, if you indeed need reminding, that Alzheimer's disease is an inexorable, devastating disease. As the colors change here, the gray matter, the living neurons in the brain, are dying. And if that isn't a persuasive animation, of course this takes place over years. Here's another view, whereas the bluer and more purple the brain here gets, the less gray matter it has. So no one would question the fact that Alzheimer's is a devastating disease. Now, one of the hallmarks of the disease is, again, if you look under brain sections in the microscope, as I showed you earlier, you see something that's kind of reminiscent with Kuru brains and also variant Creutzfeldt-Jakob disease brains, and that's these plaques. They're actually aggregates of misfolded proteins. Now, they're not prion proteins, but they still are collections of misfolded proteins, just as the prion diseases tend to induce collections, aggregates of misfolded proteins. And there was a very intriguing recent experiment where they have experimental mice that are quite susceptible to having the materials called amyloid, having deposits of amyloid develop in their brains. And they took extracts from these mice from their brains, injected them just into the abdominal cavity of other mice, and after a few weeks, they started to see exactly this: plaques, deposits in those mouses' brains. So somehow, these misfolded proteins, not prion proteins, but misfolded proteins, had made their way from the gut of the recipient mice up to their brains and were clearly somehow multiplying. Now, whether it's a knock-on kind of effect like I demonstrated or not, nobody's really sure. But the growth of these plaques looks something like this. Can we just dim the lights a bit so this is a bit clearer? So you get these fibrils, and they are somewhat helical in shape, as the one on the right and on the left. The point is that new misfolded proteins get aggregated, get collected, get recruited into these fibrils, and they grow over time. Now, of course, all of our brains probably have some of these, but in Alzheimer's disease, there is an unholy number of them. Although I must say, parenthetically, that Alzheimer's is a very mysterious disease, and some people can show many of the symptoms and not have a lot of these. But anyway, as this process unfolds, you get these proteins that aggregate into regular sort of fibrils, and then when you get enough fibrils, you get the deposits of these so-called plaques against a background of normal brain tissue. So, as I said, Alzheimer's disease, not a prion disease. It's not infectious. You don't get Alzheimer's disease from caring for a loved one who has it. But it's got these commonalities, misfolded proteins aggregating into plaque-like bodies. And this is where I think the newest frontier of prion disease study is heading. Of course there's concerns about chronic wasting disease and other human prion diseases, but is there some sort of commonality between the prion diseases, which are relatively rare, and the much more common and much more serious diseases like Alzheimer's, Parkinson's, and ALS, Lou Gehrig's disease?